All right, good morning, everybody. Hope you guys are doing well. We made it to Friday again, so that's good. Hoping the weekend's going to be nice here and not too cold, and we'll get to enjoy some outside weather before the snow's flying. Anyways, I'm going to get started on chapter 6, section 1. So, this is going to officially be the first quote unquote new stuff that we're going to do. Although some of this stuff at the beginning you have completed before, the stuff I'm going to talk about today you have done before. I'm not going to assume you remember it, so I'm going to kind of just start from scratch and get started. Here we go. So we're going to talk about Chapter 6, Section 1. This is, of course, 92520, and this is linear and nonlinear systems of equations. One thing I would encourage you to do is to make sure you're writing this stuff down in your notebook. You want to organize your notebook by date and then the chapter and the section. So at the top of your page, 92520, and then the Chapter 6, Section 1. And you can even write the title if you want. That way you're keeping your notes straight. You'll have them to be able to refer back to if you're going to need help to do any of this. So the objectives you can kind of read for yourself. These are all the objectives we're going to try to cover in this chapter and section specifically. So we're going to talk about solving systems by graphing. So what I want to do before I talk about that, though, is I want to discuss what a system is. So a linear system in this case is going to be more than one equation. You can see we have an equation right here, and that is a linear equation in slope-intercept form. And then we have a second linear equation right here that is also in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. So keep that in mind. Um, we have three different forms of a line. These two are in slope-intercept. So that kind of keys in on why this is called a linear. The word linear refers to both equations being aligned when we graph them. And system, this word right here, is referring to us having more than one equation, in this case we have two, that are going to be graphed on the same set of axes or coordinate plane. And the point of this is to determine what the solution is, if it has one. So keep in mind, in kind of a review to this, when you graph two lines, there's three things that can happen. You can have, okay, so there's a graph, and you can have a line that goes like this, and then you could have a line that goes like this. And these two equations intersect right there at that point. And so the solution to the system would be that intersection point. Now, we don't always have an intersection point. You could have a graph of two lines and the lines end up being parallel like this. And so if this happens, you would say that this system has no solution. The last thing that can happen whenever you graph two lines is you can graph a line like this, and then you go and you end up graphing that line, the other equation, and it ends up being the exact same line. So in that case, there's actually an infinite number of solutions because the lines share every point on the line in common. So three things that can happen. You can have no solutions, in which case the lines are parallel. You can have one solution, which means the lines intersect in one place. Or you can have uh, infinite solutions, which is they share all the lines. So that being said, let's get started on our problem that we need to do here. So what they want us to do is they want us to graph both of these and determine if this system has any solutions. Now, keep this in mind when you're graphing. You need to try to be as accurate as you possibly can. Now, I'm writing on an iPad, so I'm doing my best to keep my lines straight. But for you guys, definitely it would be very helpful if you used a ruler, and if you can print some graph paper out, that's even better. when you use the ruler. That way it's as accurate as possible. The worst thing about solving these systems by graphing is that it is inherently inaccurate. It's very difficult to make sure these are right. So I'm going to do my best freehanding it here on the iPad. So let's graph this first one. And I'm going to put a little squiggly line by there. So I'm going to make that one red, and let's make this one, I don't like that. Let's go with a dark blue for the second one. So we're going to graph the first one. Before I do that, I need to put my hash marks on though. Um, I'm going to go 5 in each direction. I think that should be enough. You can see my hash marks. Okay, now we're going to go with red. So the first one, you always start with the b part of the y equals mx plus b. I always tell my algebra kids, my algebra 1 kids or my pre-algebra kids when I used to teach that, b stands for beginning. So that -4 right there is the first point that we go down. So we're going to go down 4 and we are going to put a dot right there. You can see on the y-axis, it is always on the y-axis, that point. And from there, the slope is 5/2. So we're going to go up 5 and over 2, and that will land us right there. And from there, I can just draw a line that looks like this. And there's the graph of the first equation. Now the second equation, we're going to start at 3, put a dot right there on the y-axis again. It's always on the y. And then we're going to go down 1 over 1, down 1 over 1. And you're going to see we end up landing right there. We draw our line. So we've got both of the lines graphed. The last step is to write down the ordered pair if they do intersect. In this case, we go right 2 and up 1. So our ordered pair is 2, 1. Now, if we really wanted to make sure that this ordered pair 2, 1 works, you could go back in and substitute it into both of the equations, and you should get a true statement both times that you do that. Now, I'm not going to do this for all the points, all the ones that we solve, but I'll do it for this one just to show you. This is how you double check that your solution that you come up with when you graphed is accurate. So we take the first equation, y equals 5/2. We're going to substitute 2 in for x, minus 4. And I should not have put a y there. Instead of putting a y, I should have put 1 in for y. Now you can see right here, the 2's are going to cancel. We're left with 1 equals 5 minus 4. 1 equals 1. So that 0.21 worked for the first equation. Now we're going to double check the second equation. So it's y equals -2 plus 3. So I took this second equation right here and I substituted the point in 2, 1. So you can see I have 1 equals -2 plus 3. 1 equals 1. So that worked as well. So what's that tell us? Well, we substituted that point in, and that tells us, and we got a true statement from both of those equations. So that tells us our ordered pair 2, 1 is indeed a solution to the system. All right, moving on to, oh, there you go. There's a graph. I generated that on my graphing calculator, and you can see that it crosses at 2, 1. All right, let's move on to this one. So the two primary forms of lines that you're going to be given to graph are going to be either slope-intercept form or standard form. You may run into something in point-slope form, but usually it's going to be slope-intercept form or standard form. Now, most of you probably would look at this first equation right here and say, oh, that's in standard form. I need to get the y by itself so I can graph it. That is not wrong. However, that is more work to do it that way. So I want to show you a better way to graph something in standard form. And that way is to find the x and y intercepts. And finding the x and y intercepts is quite easy. The only thing that you need to do is to substitute zeros in. So when you put a 0 in for x, it gives you the y intercept. When you put a 0 in for y, it gives you the x-intercept. And we like zeros because anytime you multiply by 0, it just turns into 0 and it cancels things out. So in my opinion, this is a much quicker, easier, more efficient way of graphing these two equations that are in standard form. So let me show you. We have 2x plus 4y equals 12, and then we have x plus 2y equals negative 10. Now, rather than me writing the work out, I have it typed out here. And so what I want to show you is our first equation is this is the 2x plus, let me see if I can write that a little bit better, 2x plus 4y equals 12. And what we do is we're going to let y equal 0. Now, by letting y equal to 0, you can see that this 4 times 0 goes away. It cancels, and you're just left with 2x, which is 12, which means x is 6. Now, the thing to keep in mind is when you find out that x is 6, the ordered pair is 6 comma 0 because you had let y equal 0 up here. Now you're going to take that same equation, the 2x plus 4y equals 12, and you're going to let x equal 0. And when you do that, it cancels that whole thing out. And you're left with 4y equals 12, which means y equals 3. And once again, the ordered pair becomes 0, 3, because you had let x equals 0 to find the y-intercept. So these two ordered pairs, 6, 0 and 0, 3. You'll graph those two and then connect them with a line. And when you do, you will get the line, the graph of the first line. And you can see when I go to 6, 0 and 0, 3, 6, 0 and 0, 3. I'm going to use a black dot so you can see. Here's 6, 0 right there, and 0, 3 is right there. Okay. Now, getting the second line, I did not type that out. I have the ordered pairs there, but I'm going to show you real quick. You don't need to show this work all the time. I think it's a bit much. It's very easy. When you look, let's look at this second equation for a second here. So if I just cancel this out, you can see x is negative 10. Now, getting rid of that, x equals negative 10. Now, when I get rid of the x, you can see 2y is negative 10, y is negative 5. So it's that easy to come up with the 2 points. Now remember, that is not an ordered pair in and of itself. That's actually two ordered pairs. It's negative 10, 0, and then 0, negative 5. It's two different ordered pairs. And if you scroll down here, you can see that's exactly what I said they were going to be right there. And when you plot those 2 points, you end up getting the red line, negative 10, 0, and then 0, negative 5. And so if you look at these two lines, you can see that these two lines are parallel. Therefore, you would say there is no solution. There's no solution. So you do need to write no solution if the lines are parallel. Okay, guys, there you go. There's an overview of how to graph and solve systems of linear equations. Um, remember, please, if you can, use a ruler. I am going to attach a piece of graph paper to the post for this classwork. That way you can at least open it up and use it, even if you're going to use Notability, or if you want to print it, you can print it. That way you'll have something to graph on. So as always, guys, if you have any questions, feel free to reach out in my email. Have a good day.